So in this lesson, we are going to be doing some ionic naming. We are going to take cations and anions and figure out how to name each specific piece of them and then figure out how to put it together. By the end of this lesson, you should be able to name different ionic compounds. The information on this PowerPoint should all be review, but we're going to be using a lot of it throughout the lesson, so I wanted to give you a refresher. Cations, we know these are positively charged ions that are created by losing electrons, giving it more protons than electrons. Anions, we know these are negatively charged ions, which are formed by gaining electrons. There's more electrons than protons in the atom. And we form ions by losing or gaining electrons. Ionic bonds. This is something that we are going to talk about in the next lesson, but I wanted to give you a little bit of an overview because we are naming ionic compounds, and this is what is bringing these compounds together. An ionic bond is an electrostatic force of attraction between two oppositely charged ions, which allows a transfer of electrons. Another thing we need to know is the octet rule. This is when atoms gain or lose electrons so that they can form what we call a stable octet, which means they have 8 electrons in their last energy level or their valence shell. And why do they want this? It's for stability. If they have a full valence shell, they have less energy, which makes them more stable and more likely to not react with anything outside of that atom. Now would be a great time to have out your colored periodic table to help you remember where the metals and nonmetals are located on the periodic table. Because if you remember from the last lesson, metals form cations. They make positive ions. And the nonmetals, these form anions. They form the negative ions. So if you take a look at my pictures here, we have sodium. It loses 1 electron and becomes a +1. If you take a look at your periodic table, you'll notice sodium is in that first column. And that first column, typically all of your ions will be +1s. In the next picture I have here, I have chlorine, and it gains an electron, and it forms a +1 or a -1 anion. If you take a look at your periodic table, it's in group 17, and typically all of these, your halogens, they form -1 anions. Let's start off with naming some monoatomic ions. That means we're going to name one atom. With a cation, we're just going to use the name of the element and put ion after it. With an anion, we're going to take the root name and then add IED to the end. So some examples here, like up in my pictures, I've got a magnesium ion, and we just call that magnesium ion. With chlorine, we made it a -1 ion, so we called it chloride. So this is chlorine. We took off the INE and put IDE, so now we call it chloride. A couple rules for naming. So when the metal loses the electron, they become ions, but we don't change their name. So they still stay their elemental name. Like with sodium, we lost an electron and it became a sodium ion. Magnesium, we lost 2 electrons and it became a magnesium ion. Let's do some practice. So we have potassium here, and it looks like it's losing an electron and becomes a +1 ion. So we're just going to name this a potassium ion. The next one we have there is barium, and it looks like it's losing 2 electrons, so that means it's becoming a +2 ion, so it is a cation, and so we are going to name this a barium ion. Well, that seems simple enough, but now we want to name nonmetals, which form anions. So when a nonmetal gains electrons, they become their ion form, and we do change their name. So you take the root name, like I had stated before, and add IED to the end of it. So we have fluorine here. Looks like it's gaining 1 electron, and then it becomes fluoride. So you take off the INE and add IDE. Sulfur, it's gaining 2 electrons, becomes a -2 ion, and becomes sulfide. You take off UR and add IED. Let's do some practice. So we have tellurine there. It looks like it's gaining 2 electrons to become a -2 ion, so we know it's an anion. So it's going to be telluride, because it is tellurum. We took off the IUM and added IDE. The next example here is bromine, and we are turning it into a -1 ion by adding 1 electron. So this is going to go from being bromine, we're going to take off the INE, and we're going to change it to bromide. Alright, so now, how do we name compounds? We're going to give you a little hint here. It's basically the same as naming the monoatomic, but we're just basically putting it all together. So the first step is to name the cation using the elemental name. Then you name the anion using the root name and adding IDE. And finally, you put it all together. So let's do some practice. We've got K2S. So K, that stands for potassium. So first step, naming the cation. The cation is always the first atom in the compound. It's always the first. So we have potassium. S stands for sulfur, so we're going to take off the UR and we're going to call it sulfide. So this is potassium sulfide. Let's try the next one. We have RATE. RA stands for radium. So we've got radium as our cation. Our anion is tellurium. So we're going to take off the IUM and add IDE. So it's going to be telluride. Radium telluride. Let's try the next one. We've got CaCl2. Our cation is Ca, which is calcium. So we just name that calcium. Our anion is Cl, which is chlorine. Take off the INE and it's chloride. And the last one, we've got Mg3N2. Mg, that is magnesium, and that would be our cation. So we're just going to write magnesium. And then N stands for nitrogen. And so we're going to take off the OGEN, and it's going to become nitride. So if you've noticed as I'm writing these, I'm writing the anion with a lowercase letter instead of an uppercase at the start. And that's because this is a name. It's a full name. It's technically 2 words, but we only uppercase the first element. We only uppercase the anion. Now what happens if I throw a transition metal into the group. Remember, that is the groups 3 through 12 on your periodic table. I may have stated that these can have multiple oxidation states or ionic charges. Some of them can be a +2, a +3, even a +7. So we use Roman numerals to show which charge the atom has. And we determine that by, if we're doing just the monoatomic ion, it'll tell us its charge, or it'll have the Roman numeral. But if we're naming it in a compound, then we figure that out by looking at the subscripts, figuring out how many atoms it has, and the atoms of the other elements in the compound. Looking at the examples here, I have a copper +1 and +2. So you see there that I wrote copper and then the symbol 1 for the Roman numeral, and then I wrote copper, the symbol 2 for the Roman numeral. That is how we are going to label which oxidation state these use. Let's do some practice. Cobalt. It's got a +2 there, so that means its oxidation state is +2. So we write cobalt 2. Ti, that is titanium, and it's got a +3, so that means its oxidation state is +3, so we're going to write titanium 3. Re, that stands for rhenium, and it's got a +7 there, which means its oxidation state is 7, so it's rhenium 7. Zr, that is zirconium, and it's got a +4, so that means the oxidation state is 4, and we are going to write it like that.